Let's give a rough sketch of the graph of negative 2x to the fourth plus 16x squared minus 32. Based on this standard form of the polynomial, we can identify right from the beginning that our y-intercept is going to be at 0, negative 32. We'll want to factor and look for the zeros of the polynomial in an effort to increase the amount of detail we can add to our graph. We see a greatest common factor of negative 2. Removing that greatest common factor leaves us with this trinomial. That greatest common factor, once it's removed, leaves us with a perfect square in here. So we have x squared minus 4 and x squared minus 4. Producing two difference of squares, we have x minus 2, x plus 2, and x minus 2, x plus 2. And from there we have negative 2, 2 x minus 2's, and 2 x plus 2's. That gives us zeros at x is equal to 2 and x is equal to negative 2. Now you'll notice, based on our definition, that these two roots are both repeated roots. Each one of them has two factors that contribute to them being roots / zeros of the function. Which means when we go to graph this polynomial, we will want to touch the x-axis at those locations, but not cross it. So let's set ourselves up for a very general sketch. Here we have 1 and 2, there's negative 2, 1 and 2, there's 2. We know we're going to have a y-intercept way down here at negative 32. And we know we're going to have two intercepts here. We can clock from the beginning, based on our end behavior analysis, that this is going to fall on both sides. So outside of the 2 points that we've identified, negative 2 and 2, we should anticipate that the graph is going to fall on both of those sides. In between that end behavior is a little bit trickier. Even if I didn't know the rule for repeated roots and whether or not a graph is going to touch or cross the axis, I would have to think that right here, it's going to come back down and go through negative 32. And the reason that I would have to think that is because if I went above and I crossed over the axis at negative 2, at some point I would have to cross back over the axis to get down to negative 32, and I don't have any more intercepts. Those two are the only two that I have. So because I know that I need to go through negative 32 after going through that negative 2 on the x-axis, I'm going to have to come back down and then travel back up to the 2. The entirety of this graph is kept below the x-axis. Thank you to this square here, always producing a positive, and this square here, always producing a positive, and this negative, turning everything negative. The entirety of the graph stays below the x-axis. Looking at another example, we already have this example in factored form. We have a repeated root, x is equal to 3. So here, we're just going to touch the axis. And we have a non-repeated root of negative 1, where we're going to look to cross the axis. Giving a quick sketch out. Here at our negative 1, we know we're going to cross the axis. And here at 3, we know we're going to touch the axis. Multiplying out this polynomial, and of course not making you sit through the work, but you're welcome to check this multiplication if you'd like. 5x cubed minus 25x squared plus 15x plus 45 suggests to us that our y-intercept, is going to be at 0, 45. So way up here at 45, we're going to need to go through that point. And the fact that this is cubic with a positive coefficient suggests we're going to fall on the left and rise on the right. So to the left, we're going to fall. Then we have to get through the y-intercept. Then we have to come back down to 3. We're going to touch there. We're not going to cross there. We're going to touch there because that was our repeated root. And then we're going to send our graph off to rise on the far right. Is this a perfectly accurate depiction? Not necessarily. I'm not positive that this 45 is at the top of this heap. I'm not surprised. I wouldn't be surprised if it wasn't. I'm not guaranteed that the 45 is a maximum, but if we're drawing a rough sketch of it, we're just trying to get an impression of what it would look like. This is a perfectly reasonable approximation based on the intercepts, both the x and the y, and what we know about end behavior.